Hello student, welcome back to second video of science of grade 8. In the first video we did about density, about pressure and pressure in liquid and pressure in even gases or air, and atmospheric pressure we did, and how the pressure applies through certain experiment. I have already explained it to you in previous video. So in this video we will be working out a certain calculation regarding pressure. Now in previous video what we did, pressure is equal to force by area. This is the formula of pressure, P is equal to F by A. Now in previous question we did, in a question if force is given 30 Newton, or if it's like this, a person is applying 20 Newton force in 30 meter square area, then find the pressure. Then force was 20 Newton, area was 30 meter square. We deducted it and we got the answer like this, and 0.67 Newton per meter square. And I told you SI unit of pressure is Pascal. So Pascal PA. So 1 Pascal, if you say SI unit of pressure is Pascal PA. So whenever we are talking about 1 Pascal, it means 1 Newton force is applied in 1 meter square area. Now sometimes question will not be like this, a bit different. Certain other values will be asked in the same formula. So for example, you can check page number 129, question number 3. When the wind blows, it creates pressure on any surface it blows against. A large window has an area of 3.5 meters square. Area is given now. A 3.5 meters square. If the wind causes a pressure of 2000 Pascal. Now here PA, Pascal means pressure. Pressure has been given already. So P is equal to 2000 Pascal. Your question is on the window, what force acts on it? Now your question is force. You have to calculate F. But regarding F, P and A, we have only one relation. That is P is equal to F by A. Now, the way we did, I have explained it to you in chapter 1 of mathematics. Same thing you will be applying in here. Whenever relation is like this, you need to find A. F, for example, in this question. Now F will remain here. A has to be sent to the other side of equal. So whenever we send it, sign will be changing. A is divided. So while sending it to the other side, it will multiply. So P, it will come here and into A will be equal to F. Now P, 2000, we already have put the value 2000 Pascal. A we have 3.5 meter square. Now multiply them. 1 0 cancel, point gone. So 200 into 35, 2 zeros, let it be there. 35 into 2, 70. So 7000 SI unit of force is Newton. So this is how we calculate for force. So similarly, sometimes in the question P and F will be given, they will be asking you to find A. Whatever. But you just have the relation P is equal to F by A. You use that and calculate whatever the unknown values are there. So we have completed almost all the topic regarding this chapter. Density, pressure and everything. And now we are in the 9.7, unit 9.7, the turning effect of force. So we will start from here. Now whenever we call turning effect of force, what do you understand by that? Here in this video I have put up one picture. You can see there a person is holding a spanner and then revolving around the nut. So whenever you might have used the spanner also at home, or you might have seen your father or your dad somewhere using it. So you know that when the person holds the spanner and revolve or rotate around it, slowly the nut will start to loosen up. Now why do you think it happens? Because there is a turning effect of force which will help the nuts to get loosened up. Regarding that type of cases we'll be learning here. Now for example, a door. You have seen a door at home. In the door in the corner, suppose this is a door. In the corner you can see like this kind of nuts in here. So whenever you will be opening it, this particular nut will be having the turning effect of force. So it will try to rotate around and the door will be opened up or closed. So now what do we call those kind of things? Even another example, here in the video also you can see like this kind of thing is there and a straight scale is there. So suppose here I am putting a weight, an apple for example, and here an orange. Now there is a fixed point here, and through this fixed point, whenever we apply force in here, either it will move this side or this side. If I apply more force here, for example, this object has more weight, suppose 80 Newton, it has 40 Newton, then since its weight is more, it will try to turn this side, and if I apply more force here, it will try to turn this side through a fixed point. This fixed point we call it pivot. P-I-V-O-T, pivot. So the particular object or the scale will move, if it will be moving this side, we call it clockwise direction. Remember, when the weight force is applied more here, it is going to this direction. So that means it is going clockwise. Now what do you mean by clockwise? You know that in a clock, 12, 1, 2, 3 will be going, so it will be going in this direction. But if it goes, if its weight was more in the other side, then it will be going in this direction. Now this direction we call it anti-clockwise direction, against the clockwise, that is anti-clockwise direction. So this, what do we call it? This turning effect, whatever is happening, either this side or the other side to the fixed point pivot, what do we call it? We call it moments. Now you might have learned this word in English, moment, that is different, but physics moment is different. So basically, moment is the turning effect of force being applied through the certain fixed point called pivot. The turning effect of force through the fixed point pivot, we call it moment. Sometimes question will be asked, what do you mean by moment? Explain. So this. Or even another example we have, seesaw. You might have played during your childhood, or you might have seen also, even if you have not played, it would be something like this. Pivot will be there in the middle, a person will be sitting here, another person will be sitting here, and they will be applying force. So once you might go down, once you might go up. That is also due to effect of moment. Now, how can we calculate moment? Moment basically depends upon two things. How much force being applied? Here only you understood. If force is more, it will be going in this direction. That means it has to depend on force. So suppose this is 70 Newton force being applied, down. So for example, here 80 Newton force has been applied, down. Suppose this distance from pivot to person, wherever that person or weight has been placed. Moment even depend upon that distance also. So if that distance here is 2 meter, and for example here is 4 meter, okay. Now how does the movement differentiate? Let us see. So you know that movement depends upon force also and the distance also. So we have formula m, movement m is equal to force into distance. So let us calculate for this case. Here force 80 Newton. This person's weight 80 Newton means its weight is 80. So weight and force are basically same thing. In class 9 you will be learning about it, that weight and forces on the same planet are same thing only. So here for example a person weighing 80 Newton, he will be applying force 80 Newton in downward. So force is 80 and distance here is 2 meter. So 8 into 2, 160 Newton meter. Now similarly let us apply in the other side. Again we have same thing, movement 2, force into distance. We have force here but 70 and here 4 meter. Distance 7, 4, 20 to 80 Newton meter. Now see, this value is lesser than 280. So it not only depends upon how much is the weight being applied or the force being applied, it even depends on the distance. Now here between these two cases, obviously this person will have to move down because distance is more. So from these cases also you can understand movement m is equal to F into D. If ever comes for calculation, you will do like this, and you can understand whether it will go clockwise or anti-clockwise. In this case, it will be going clockwise direction. Now, there is another thing also. We call it principle of moment. In similar case, principle of moment. What does it say? So principle of movement says that through a fixed point pivot, if force is being applied in this direction also, here also, suppose here person is applying 80 Newton, here 70 Newton. In that case, certain distances are there from here to here, fixed point pivot, here to here also certain distance. So principle of movement says that if this particular scale balance has to be in equilibrium, equilibrium means not moving either side, nor clockwise nor anti-clockwise. While playing seesaw, you might have noticed it. At a certain point, it would be in a fixed place also. It won't be going up or down. That position, we call it equilibrium position. So for equilibrium position, in order to be there, movements in clockwise direction and movements in anti-clockwise direction have to be equal. That is what we call it, principle of movement. So movement in clockwise is equal to movement in anti-clockwise. So this particular relationship, we call it principle of movements. So sometimes they will ask you in question, what do you understand by principle of movement? So principle of movement states that for balance to be in a fixed position or for balance to be in equilibrium, the movements in clockwise and the movements in anti-clockwise direction is always equal. So regarding this also question will be asked. Suppose in this same case, if the question was, in a seesaw, two persons are sitting in the opposite direction. Person 1 is 80 Newton force applying and the person 2 is applying 70 Newton force. And if the person A from the pivot is at the distance of 4 meter, then what would be the person, second person from the pivot, what would be the distance if they are in equilibrium position? Now what do we have relation regarding them? Clockwise and anti-clockwise movement has to be equal. So let us calculate movement using the previous formula. F into D. Similarly here also F1 into D1. I am putting 1 because both the force and distances has to be different, not same. So here F is 80. Distance is 4. Here F is 70. Distance you are supposed to find. Now you are calculating this, same like application of mathematics. It will stay here. Now 70 will go to the other side, but it is being multiplied, so it will go and divide. So 80 into 4 by 70. Now you calculate it. 00717.10717 at 1937. 4 is 28. 1.14 into 4. Multiply them. 4 4 is 16. 4 1 is 4 5. 1 4 meter. That means the distance this person is sitting from the pivot is 4.56 meter, nearly 5 meter. Rounding off if you do. Now this type of question also will come for the equilibrium case. So every equilibrium is there for the case of turning effect of force. Remember, movement in anti-clockwise and movement in clockwise has to be equal. So now, by this your 9.7, 8 and 9 is also over. So basically I want to wrap it up what we have done. In video 1, part 1, we learned about density, how it works, how to calculate mass and volume for regular and irregular object both. And again we did calculation of density is equal to m by v, completed. And we did pressure. What is pressure? How to apply formula and examples of high pressure and low pressure for the desert area, wearing of school bags and all cases we have completed. And even pressure in liquid and even in water also, how to calculate we have done. And in air, how does the pressure works it out, we have seen with the egg experiment also completed. Now today we have in this video we have even completed regarding turning effect of force. What do you mean by it? What is movements? What are the various examples of turning effect of force? and in equilibrium position, how does the principle of movement works, has been completed. So by this particular whole unit is over. Now I want you to complete all the questions in end of unit review of 9.9, that is page number 138 onwards. Please complete all the questions and submit it as an assignment. If there is any doubt, you can call me or WhatsApp it to me, the way you have all been doing so before. So please complete this, and please grade 8B, give it to me, and 8A, give it to your respective science teacher. Thank you.